Welcome to Mimi's Math channel. On this video, I'm going to discuss the sine-cosine cofunction rule. Sometimes you'll hear it referred to as sine-cosine complementary rule. So if you look at the ratios that are shown here, that's a reminder of what sine, cosine, and tangent formulas are. For our first example, I'm going to find the sine and the cosine of the acute angles, which are the two angles across from your right angle, and those angles are complementary. So keep that in mind for this entire video. So for sine of D, sine means opposite over hypotenuse. D is over here, and that's going to be my opposite side. So that goes on top. And then hypotenuse is always directly across from your right angle symbol, and that's going to go on bottom. Now, what I see is the 5 and the 10 can actually be simplified. So I do not want to leave it in this form. I want to go ahead and keep simplifying. So I can divide both by 5, which leaves me with √3/2. So that's the final answer. Now, if I go to cosine of f, what I want to look for is adjacent. And adjacent means next to. So we have two things next to. However, we recognize that this one that's across from my right angle symbol is my hypotenuse. So that is not adjacent. 5√3 is adjacent. And over hypotenuse. What you will notice is that it is the same as the one that we just did a few minutes ago. So I have two angles that are complementary, meaning if I add them together, they're going to equal 90. But if I take the sine of one and then I take the cosine of the other, they're going to end up being the exact same side length. Excuse me. All right, so cosine D this time is going to be, again, this is hypotenuse. So what's next to it is going to be adjacent. So that's going to be 5, adjacent over hypotenuse. I notice again, I can simplify. If I divide both by 5, I have 1/2. And then for sine F, I'm looking at the opposite over the hypotenuse, which again is the same ratio, 1/2. So that's how that works when you're trying to find the sine and cosine of those acute angles. For example, 2, we're going to write sine in cosine terms and cosine in sine terms. So remember when I said keep in mind about complementary angles? Complementary angles mean that you add the two angles together and they equal 90. So if I am writing sine in terms of cosine, I already have the sine over here. So now I have to set it equal to cosine. And if I set it equal to cosine, I have to remember that I am trying to take the complementary. So that's going to be 90 minus whatever my angle is. Since I don't know my angle, I'm going to use this theta symbol. Now, for the next one, I have sine already, so I want to write it in terms of cosine. And I want to, again, take 90, but this time I do have an angle measure of 35. So 90 minus 35 is 55. I'm gonna put my degree symbols here. And then for the next one, I'm going to take cosine and write it in terms of sine and take that angle 54 and I want to subtract it from 90. So 90 minus 54 leaves me with 36 degrees. So that's how you do those type problems. And then the last type problem is to find an unknown angle. And I have two examples here. What I know is, again, complementary. So I can really just get rid of the trig ratios and add these two angles together. And I know they're angles because I see degree symbols. Plus 3x minus 20. Together, they're going to equal 90. So now I want to combine like terms. I have a 3x and a 3x. So that's 6x. And then I have -10 and -20. So I'm adding them together because they're like signs. So that's -30 is equal to 90. And now I want to add 30 to both sides. And I'm left with 6x is equal to 120. Divide both sides by 6. X is equal to 20. But that's not what I'm trying to find. I'm trying to find then the unknown angle. So that means I have to substitute back in for both angles. So for the first one, I have 3 times x, but we just said x is 20. And then we're going to subtract 10 from that. So 3 times 20 is 60. 60 minus 10 is 50, and we're talking angles, so that's going to be degrees. And then the next one is going to be 3 times that same x, but this time minus 20. So 60 minus 20 is 40 degrees. So these are my two angle measures. And then the very last example that we have, we're going to again go ahead and get rid of the trig ratios. We're going to take each one of the angle measures, add them together. And because they're complementary, that means we set it equal to 90. And now we just combine like terms. We have a 5x and plus 1x, which is 6x. And then we have negative 12 plus 54. That is going to be plus 42. Set that equal to 90. Subtract 42 on both sides. We have 6x is equal to 48. Divide both sides by 6. We have x is equal to 8. And again, we want to find the angle measures. So we're going to have to substitute in for x. We have 5 times 8 minus 12. And that's going to be 40 minus 12, which is 28 degrees. And then we have 8 plus 54. And once I combine those two, that's 62 degrees. All right, so that is it for the video. Thumbs up, like, and subscribe. Have an awesome day.